Well, hello and welcome again to this video. So, I have actually been pondering around with the ideas that you guys have proposed on your feedback and for the lecture, and I really like a lot of this. I hope that you're enjoying this as much as I am. I know that there were a lot of mistakes in the first video that I will hopefully try to fix in the coming few videos, starting with this one basically. So the idea right now is basically to post this video for you guys to get an idea of the first part of the project. It's not really the first part of the project, but it's stuff that you will need to start with the project. Uh, and well, I will provide sort of a tutorial that is already now in Cambro, actually uploaded, that guys can use to start and get rolling in installing an environment and getting a bit more uh, learned about Python and about the whole ecosystem. So this is I actually thought also that it might be a good idea for you guys to have the project in different, well, not different parts, but into different modules where we can basically have sort of checkpoints, and this would be the idea. So although I call this document operating systems course project, it's not really the course project document, but it's rather an intro so that you guys can start getting more used to the environment. Followed by this video, I will actually post another video where I will start really getting into the Linux kernel from today, roughly. So let's start by a few things that I would like to tell you on your or on setting up the environment. The main idea of this project is, of course, to give you hands-on experience with the Linux kernel, and well, to expose you to how does your different architecture, your platform, affect the Linux kernel in some way. That's one part of it, but also how to basically go navigate through the different modules in Linux, how to pinpoint what you need to change, and how to change actual code. So this lecture or this video, it's not an official lecture. This video is all about this basically. It's all about what you guys can learn, can start learning with regards to the operating system. So a few practicalities. We mentioned already some of these practicalities in the course in the first lecture, which unfortunately some of you apparently were not able to come to, but I hope that this will kind of cover quite a bit of what we said. The project, as I said, is to be done in groups of 3 students under extreme circumstances. Basically, if the numbers do not add up, we will allow for project groups of 4. I have not received 10 groups as far as I know, so there are quite few groups that are still missing. Please send me your groups as soon as possible. We said last in the first lecture that we would like to have them by today. We did not have them, unfortunately, all of them by today. So please send them so that we can actually start doing stuff. The project, as I said, will be divided into parts. These are, to cover different parts of the course. So it will not be something that you can start playing with from the very beginning. But after each lecture, you will learn a bit more so that you can actually start doing a bit more in your project. And the aim is basically to cover as much as possible in the Linux kernel in your project. Plan your time, of course, as we said, as this will not be done on the last night of submission. So you're not going to basically be able to think that, oh, maybe I can submit it, maybe I can pull an all-nighter and submit that. Well, you do not want that. We do not want that. We want you to basically be as much relaxed as you can when hacking the kernel. You need also to be at a very good mood, so bring your coffee, bring your tea, bring your whatever that you like, and just try to be in a good mood while hacking through the kernel. As I said, these parts will act as sort of soft deadlines for you guys, so that when you start your new module sort of, or your new part, you sort of have some feedback on what you have done, and you just do not come at towards the end of the project and realize that, oh, I've been doing things in the wrong way. These deadlines, these soft deadlines, are not mandatory, so I'm not going to force anyone to submit them. You're not going to be graded on these. I just want you to think of these as your checkpoints and as things that are supposed to help you. Okay? And well, if you submit something in these deadlines, to get proper feedback, we need also proper writing. And a well-written report does not mean that it's long. You can convey as little as you can convey very little in a very long report. I can show you examples of these reports that I have personally written, but you can also basically convey a lot by just having one-page report. And one thing that I have to note, please, when you submit a report, make sure that you have your names or some identifier, some unique identifier to identify whatever you have submitted in an easy way, because I do not like going through emails basically to figure out who submitted that and do some character recognition based on your first page. So please help us so that we can help you. I have to say that I will not accept any reports that are not submitted with a proper basically introduction. And by introduction I mean who are you. That's the most simple thing that you write on any report. So give us well written reports and we will give you feedback. Then you will have a project submission final deadline. I will actually add it to Cambro today. I am, as I said to a few of you, I'm struggling with Cambro, but I'm hoping that this will get better. I'm leaving Brussels tomorrow and I will be in office on Friday. So things will get better when I have basically help. This is basically the first course that I ever give in Cambro, so it's kind of crappy. And for some reason, Jan Erik has not been added to Cambro, so things are there are some initialization issues here that we will need to fix, and we have not been able to fix due to basically travels. But this is getting better. And towards the end on the project deadline, I expect every group to basically come in and give a presentation of what they have done, of their solutions. But I also, as I said in the first lecture, I will also have, or we as teachers will also have face-to-face meetings with each and every student, because we do not want free riders. Okay? There is absolutely no problem if you get help on your project from your friends, from your peers, but at the same time, I do not want this to end up in a situation which happened in a few projects that I have seen, where basically two people are working and one is not working at all. So if you are, there's nothing wrong with being weaker, right? I mean, everybody of us has a weakness in the terms of the subjects that one has studied. So I can actually confess that one of my major weaknesses is kind of very highly related to operating systems, and it was my compilers course. I was probably one of the weakest students on earth on this course. And that's totally fine, but as long as you exert enough effort to catch up. And as a group, I expect the remaining people in the group to help their peer. So if you have someone who's weaker than you, he might be much stronger than you in C coding, for example, and he might be a huge asset in that. So I really want you to learn how to work together and to produce things that make sense. So as I said, we will divide the project into modules, but today I will start by basically telling you a few things about how to set up the environment and get a working development environment. So first of all, we are, as many of you know, we are going to be using our Pis, Raspberry Pis 3. Right now the lab is all set. We just need to fix the Raspberry Pis in the lab and to fix some access control so that we do not get into we want the Raspberry Pis to stay in the lab, basically. So we will have actually the place dedicated to us and maybe some students from one other course, but they will hopefully not use the lab that much, and there will be very few of them anyway. So, but the Raspberry Pis are all yours. So this is actually an instruction on how to build the kernel for Raspberry Pi 3s. This is from the official Raspberry Pi webpage. You don't need a Raspberry Pi today to basically do that, right? So what you need is basically to go over this and to get an idea of how to actually get and build the kernel. This is kind of your first task. And well, you're not going to do anything in this project if you're not able to build the kernel and flush it on Raspberry Pis, because well, that's mandatory, right? You want to test your stuff and you want to run somewhere, and that would be your Raspberry Pis, and hopefully not your laptop, because well, I do not want you to screw up your laptop. The second part will be actually to get a working development environment. And now, I mean, there are many people who have different preferences on what environment or what editor to use. So some people are just hardcore Vim / Emacs users, and that's totally fine. But you need something that will help you. So Vim on its own is kind of well, it's good for a file, but it's very hard to basically manage the whole kernel with Vim unless you're really hardcore. And then this is not for you. I mean, whatever I'm saying right now is not for you. You can just close the video over here and go do some more hardcore stuff from your experience. But if you're like the normal average Joe programmer, then you need some other environment. And then there is actually an environment that uses Eclipse. So I know that a lot of you are probably familiar with Eclipse, so I chose it. And it's cool. It's based on Eclipse CDT. And well, you have basically some instructions on how to do the installation over here, on how to use CDT to navigate the Linux kernel source. For building the code after you make any changes, I highly suggest that you do not use Eclipse for this, but rather go and use this part, the official way to build it. Okay, but use this as basically your dev environment. So there are other options that you can use for basically getting for Linux working development environment, and well, the internet is full of these. So if you are wondering what environment you should use, you can just search the internet. If you have another favorite editor, say Vim or Emacs, there are a lot of these sort of add-ons to make Vim more usable for this hardcore stuff. So this is a rather short video. It's meant just to introduce you to what lies ahead, and I would like you to basically start pondering with this, and there will be more very soon on the actual work to do in the project. But before that, I will actually record a video tonight or tomorrow morning at the latest on some very basic C and Linux stuff. Just a few comments on the reviews, or basically the feedback I got from the first video lecture. I think I mean, I already said that I really like them, but really do not basically feel shy to tell me that anything is wrong. Okay, so for example, there was something about my breathing in the microphone, which I hope it gets fixed in this video, because I mean, here looking at this, I thought, oh, there must be an obvious solution to this. Looked up at the internet, and apparently I should have enabled something in my audio settings while recording in the same exact program that I'm using for recording. So your feedback can be something that I mean, it might look just cosmetic, but well, it's not. I mean, some people get really annoyed by this, and I hope that this is better. And if it's not, please put that in your feedback. I would like to have this feedback, this constant feedback loop, this very tight feedback loop between you and me. And next, I will see you on Friday. I will also have some more to say about some of the feedback and how we can address this together. Thank you and have a good night/good morning.